Every star you see in the night sky is alive, it breathes, it burns, it grows, and one day it must die. But what truly happens inside a star in its final moments? How does a peaceful ball of light turn into one of the most powerful explosions in the universe? Tonight, we dive into the heart of a dying star. A star begins its life as a cold, quiet cloud of gas, but gravity squeezes it tighter and tighter until the pressure becomes so intense that hydrogen atoms fuse together. This process, nuclear fusion, is the star's heartbeat. It produces enormous energy, balancing gravity and keeping the star stable for millions, or even billions of years, but no star lives forever. Inside the core, hydrogen is slowly turning into helium, eventually. The star runs out of hydrogen fuel, gravity pushes inward, the star's core collapses, and the star swells into a red giant or red supergiant, depending on its size. Temperatures soar to hundreds of millions of degrees. New fusion reactions begin. Helium turns into carbon, carbon into oxygen, oxygen into neon. Layer by layer, the star becomes like an onion, each shell burning a different element. But once it reaches iron, something dramatic happens. Iron is special. It cannot produce energy through fusion. Instead, it absorbs energy. So when the core fills with iron, the star faces a problem it cannot escape. Gravity, which the star has been fighting its whole life, suddenly wins. The core collapses. In less than a second, atoms are crushed. Electrons slam into protons, forming neutrons. A dense neutron core forms, smaller than a city, but heavier than our sun. Then comes the blast. When the collapsing core hits its limit, it rebounds outward like a spring-loaded explosion. This shockwave rips through the star's outer layers, releasing more energy in 1 second than our sun will emit in its entire lifetime. This is a supernova, one of the brightest events in the universe. Stardust, metals, radiation, all thrown across space. Gold, silver, uranium, elements that could not form inside normal stars, are created in milliseconds and scattered into the cosmos. Everything around us, everything we are, comes from the death of ancient stars. We are literally stardust when the explosion fades. What remains depends on the star's size. If the star was massive, but not too massive, the collapsed core becomes a neutron star. Imagine a teaspoon of this material weighing billions of tons. It spins rapidly, emits beams of radiation, and becomes a pulsar, a cosmic lighthouse in the dark. But if the star was truly colossal, gravity crushes the core so much that nothing can escape, not even light. A black hole is born, a tear in space-time, a star that has died, but left behind a doorway to the unknown. A star's death is not the end, it is a beginning. The explosion seeds space with heavy elements, which gather into new stars, new planets, and eventually life. Every atom of calcium in your bones, every atom of iron in your blood, every atom of oxygen you breathe was forged in a dying star. The universe is a cycle of creation and destruction, light and darkness, life and death, and the death of a star is one of the most beautiful endings the cosmos has ever written.